In this video, we're going to be subtracting with decimals. Again, anytime we're working with decimals, place value is incredibly important. So when we're subtracting decimals, we need to line up the place values. So we're lining up those decimals. Another really important piece when we're working with subtraction is if we don't have enough, we have to borrow. And when we subtract, it's always left minus the right, or top minus the bottom number. And it has to go in that order, otherwise you're changing the process and the meaning of that subtraction. And I'll explain more as we go. Again, you'll see that estimating is going to be helpful with this operation, especially with those decimal placements. The first number listed always has to go on the top. It's listed first, it's going to go on the top because that's what we are starting with. That's our total number, or our total value. So we put the total up on top, 5 48/100ths, and we're going to subtract the second number. So our second number is the part that we're subtracting that goes on the bottom. Again, lining up our decimals so that all of our place values line up. The 4 and the 2, they're both in the tens place. The 8 and the 7, they're both in the hundredths place. That's going to be super important. We're going to estimate to help check. Rounding to the nearest whole number, 5 48/100ths would still be just about 5. Subtracting, it'd be 0 27/100ths. Well, the 2 isn't going to be enough to round it up, so it's about 0, giving us about 5. So our answer should be around 5 when we subtract. 8 is the number we start with, and we want to subtract 7. 8 is on top, which is why we're starting with the 8. 8 minus 7 gives us 1. 4 minus 2 gives us 2. The 5, we're not subtracting anything. We could put a 0 there, and that's still going to leave us with 5. And our decimal has to come straight down. And you'll notice that 5 21/100ths is really close to 5. So we have our decimal in the right place. If we look at this next one, we have more digits in our numbers, but the process is still the same. We need to line up the decimals so all of our place values are also lined up, and subtract top minus bottom. This one's listed first, so it's going to be written on the top minus the one that's listed second on the bottom. So when we write this problem, we have 156 86 thousandths minus our decimal goes straight down underneath it, and then everything else we can fill in, making all of those digits also line up. It's not just about lining up the decimal, all of the digits also have to match. So the 5 would go underneath the 0, and then the 6. You'll notice that we have extra spaces on both sides. Underneath the 6 we can put a 0, and underneath the 1 we can also put a 0. So we're filling those empty digit spaces with zeros. Let's estimate. 0 is not going to round that up, so we have 156 rounding to the nearest whole number. The 5 is going to round the 2 up, so that's going to make it 13. Again, lining up place values, just like we do when we have decimals. 6 minus 3 gives us 3, 5 minus 1 gives us 4. We're not subtracting anything from the 1 there because there was no digit, so it's still a 1. So it's going to be about 143. So let's do the actual subtraction. 6 minus 0, still 6. 8 minus 6, they're lined up nicely, gives us 2. 0 minus 5, again, always top minus bottom. Well, you'll notice the top number is smaller. We don't have enough. We cannot take away 5 from nothing. So we have to look to the next place value over and borrow. Because it's in the next place value up, it's much, much bigger. So this is kind of like we have 60. So we're going to borrow, make this a 5. We're borrowing 10, and this 0 is going to become 10. We borrowed 10. Now 10 minus 5 gives us 5. We had enough because the top number was bigger now. Then we can go on to the next place value. 5 minus 2 is enough because the top number is bigger, so we can subtract 5 minus 1 is 4, and 1 minus 0 is still 1. This wouldn't be our answer until we bring that decimal point straight down. So if it's helpful to do that right away, you can, using our estimate to make sure that it's in the correct place. 143 to the left, 143 again. So that would be our answer. You'll notice this time that our first number written that would go on the top doesn't have a decimal in it. But we know that the decimal is always at the very, very end of the number if it's not listed, because 9 is in the ones place. So that one's going to go on top, and it's going to be helpful to put a decimal there so that we can line everything else up underneath it. The number that we're subtracting, the second number listed, goes on the bottom, lining up the decimals, and all of these digits come after the decimal. So we'll say 2, 6, 4. We're going to want to fill in some zeros so that we have something to subtract from. Again, an estimate's going to be really, really helpful for this. 9 is just 9 minus, if we round this to the nearest whole number with a 0 in front, 2 is not enough to round it up. So we're going to subtract 0, and it's about 9. So it's going to be really close to 9. Not exactly 9 because we're subtracting something, but close to 9. Again, the top number would have to be bigger to have enough. We don't have enough to subtract 4 because the top number, the top digit is smaller. So we have to borrow, but we look next door and there's nothing to borrow because it's already 0. So we look next door again. Again, it's a 0, so we have nothing to borrow. So we look next door again. We can borrow from the 9, making it an 8. We borrowed 10 from it, so this 0 becomes a 10. But we wanted to get it all the way over here. We were trying to borrow for the first digit. So now we're going to borrow again from the 10, making it a 9. And this next 0 becomes a 10. But we still didn't get it far enough to actually subtract the ones place. Or excuse me, the tens, hundreds, the thousands place. So we do it again. Borrow 1, and this one becomes a 10. So we had to borrow quite a few times. Then we have enough to subtract. 10 minus 4 is 6. That also helps take care of the next ones as well. 9 minus 6 is 3. 9 minus 2 is 7. Crossing out the numbers and writing directly above it in a really neat way is going to be helpful when you subtract. Then 8 minus 0 is still 8. It's not just 8,736. That wouldn't make sense if we started with 9. So our decimal has to come straight down. And you'll notice that those are very close to each other. One final problem. In this last one, again, lining up those decimals. So we have 1 and 583 minus, because it was listed first, it goes on top. The number listed second goes on the bottom. That's the number that we are subtracting. Lining up those decimals, there's nothing to the left, so we have a 9 and a 2. We'd want to fill in zeros to those extra digits because we have more digits on top. An estimate will be helpful. 1 and 583 thousandths is going to round up to 2. Subtracting the 92 hundredths is also going to round up to 1. So when we subtract, we get about 1. So let's do the actual subtraction. 3 minus 0 is 3. 8 minus 2, the top number is bigger, so we can do that subtraction, gives us 6. 5 minus 9, you'll notice this time, in the tens place, the 5 is smaller. The top digit is smaller, so we don't have enough. We have to borrow from the next place value over to the left. Making that a 0, we're borrowing 10. 10 plus that 5 gives us 15. And then we have enough to subtract. 15 minus 9 gives us 6. 0 minus 0 is 0. Again, bring our decimal straight down. And if we were to round this number, it would give us the estimate that we had, so we know that our estimate is close and our decimal's in the right place. Whenever we are subtracting decimals, you must line up those place values, starting with that decimal so everything else lines up. Organization is super important. and it is always the top number minus the bottom number. The top digit has to be big enough to subtract the bottom one, otherwise you would need to borrow from the next place value to the left. Carefully showing your work.